The winter of the 1940s was not theoretical. In Europe, North America and the Soviet Union, millions of people lived in wooden structures heated by little more than timber, masonry and disciplined design. Fuel was scarce, electricity unreliable, and modern insulation materials did not exist at scale. Yet log cabins built during the wartime era consistently maintained warmth with minimal fuel. This was not accidental. It was the result of accumulated knowledge passed down through frontier building traditions and refined under wartime constraints. Understanding how those builders thought about heat reveals principles that modern construction often ignores. Why wartime log cabins were designed as thermal systems, not just shelters. WWII-era builders did not treat cabins as static boxes. They treated them as thermal machines. Every structural decision, from log diameter to roof pitch, was tied to heat retention and heat distribution. Thick logs were chosen not only for strength, but for thermal mass. Wood absorbs heat slowly and releases it gradually, stabilizing indoor temperatures over long periods. Modern framing, with thin studs and synthetic insulation, often lacks this thermal inertia, leading to rapid heat loss once a heating source stops. A practical application of this principle today is choosing dense natural materials where possible. For example, using solid timber beams, interior wood paneling, or masonry features inside a home can improve thermal stability even when modern insulation is present. How log orientation and joinery reduced heat loss in extreme cold. Wartime cabins rarely used random log placement. Builders oriented logs horizontally with tight saddle notches or dovetail joints, minimizing gaps where cold air could infiltrate. These joints were designed to tighten as the wood settled, not loosen. Moss, clay, lime mortar or animal hair were often used as chinking materials because they expanded and contracted with temperature changes rather than cracking. Modern builders, can adapt this logic by focusing on air tightness rather than just insulation thickness. Sealing structural joints, reducing thermal bridges, and using flexible sealants where materials move, that can really replicate the effect of traditional chinking without abandoning modern standards. Why did cabin placement matter more than insulation thickness? W2 builders understood that location was actually the first layer of insulation. Cabins were rarely placed on exposed ridges or open plains, unless military necessity demanded it. Instead, they were built on the leeward side of hills, near tree lines, or partially embedded into terrain. This reduced wind exposure, which honestly is often the primary cause of heat loss in cold climates. A modern parallel, really, is strategic landscaping and site planning. Windbreaks created by trees, fences or earth berms can reduce heating costs dramatically. Even suburban homes can benefit from planting dense vegetation on prevailing wind sides or using terrain features to shield structures. Roof design played a crucial role in controlling both heat flow and snow load at the same time. Wartime log cabins, often featured steeply pitched roofs, not just to shed snow, but also to create these insulating air pockets. The attic space, in particular, acted as a thermal buffer zone between the heated living area and the outside environment. Builders, whenever possible, avoided using metal roofing, preferring wood shingles or layered materials instead, since those reduced heat conduction. These days, homeowners can apply the same principle by, well, improving attic insulation and ventilation, while making sure to avoid direct thermal bridges between roof surfaces and living spaces. Creating layered roof systems, rather than relying on single-skin structures, really echoes the logic of those WWII-era designs. Now, let's consider why fireplaces were positioned to heat the entire structure, not just a single room. In many WWII cabins, the hearth was actually placed centrally, rather than against an exterior wall. This clever placement allowed heat to radiate evenly through multiple rooms. Chimneys, you'll notice, were built with thick masonry to retain heat long after the fire had burned down. Some cabins even had stone walls integrated right next to the fireplace, acting as heat reservoirs to keep things warm well into the night, too. A practical modern step is, well, reconsidering heating source placement. Centralized wood stoves, masonry heaters, or radiant wall systems can distribute heat more efficiently than perimeter heaters. Even in modern homes, adding thermal mass near heating sources can, significantly improve efficiency. How floor construction prevented cold from rising into living spaces is pretty interesting. Wartime builders rarely placed cabin floors directly on bare ground. Raised foundations, stone piers, or packed earth layers created air gaps beneath the structure. These gaps reduce ground moisture and cold transfer. Floors were often built with thick planks and sometimes layered with natural fibres or straw. Modern adaptations include insulated subfloors, vapour barriers and raised foundation designs. Even modest improvements in floor insulation can honestly replicate the thermal advantages of traditional cabins. Small windows in those old cabins weren't just a sign of primitive building, not at all. During the Second World War, glass was actually quite expensive, and folks already understood that heat loss through glazing could be a real problem. So windows were placed carefully to catch as much sunlight as possible during those cold winter months. But at the same time, they were set up to avoid the worst of the prevailing winds. And, well, at night, heavy curtains and sturdy shutters added another layer of insulation to keep the warmth in. Nowadays, I suppose, this old wisdom shows up as thoughtful window placement instead of just putting in loads of glass everywhere. With high-performance windows and a bit of clever orientation, we can strike that same balance between letting in light and holding on to heat, just like those wartime builders managed, almost instinctively. And then there's the matter of fuel, how its careful use really shaped the way people built. Scarcity during the war meant builders had to design homes that used as little fuel as possible. That's why you see those compact floor plans, low ceilings, and efficient room layouts. They all help cut down the amount of air that needed heating. Corridors were kept to a minimum, and rooms were arranged so they could share warmth, making every bit of fuel count. So modern homeowners can apply this by, really reconsidering spatial efficiency. Zoning heating systems, reducing unused space, and designing compact living areas can, well, dramatically reduce energy consumption without sacrificing comfort. It's curious why modern construction seems to have forgotten these lessons. After the Second World War, industrial materials, cheap energy and mass production really reshaped building practices. Efficiency was, well, replaced by convenience, and thermal design got outsourced to mechanical systems rather than being embedded in the architecture itself. The result, frankly, is buildings that depend on constant energy input rather than any sort of structural intelligence. The enduring relevance of wartime log cabin heating principles is honestly something we shouldn't overlook. Those Second World War log cabin builders weren't romantics or hobbyists. They were practical engineers working under some pretty severe constraints. Their solutions were shaped by necessity, not nostalgia. By studying their methods, modern builders and homeowners can, I think, rediscover a form of thermal wisdom that reduces dependence on technology and restores a bit of resilience. Understanding these principles isn't about rejecting modern materials, not at all, but about integrating old logic with new tools. When architecture itself becomes part of the heating system, energy efficiency stops being just a feature and, well, it becomes a structural reality. If this exploration of wartime building knowledge revealed something valuable to you, go ahead and subscribe to the channel for more serious history with practical relevance, and, share this video with anyone who believes that the past still has lessons worth recovering.